The eighth lesson in Module 12 is about slope and equations of lines. The learning objectives of this lesson are: classify lines as parallel, perpendicular, or neither by comparing the slopes of the lines, and then to classify lines as parallel, perpendicular, or neither by comparing the equations of the lines. Just by the slopes or by the equations, you can tell whether the lines are parallel or perpendicular or neither. So we will see how to do them. Before that, keywords of this lesson are parallel, perpendicular, slope. We have come across this before already. Now we will go through them again. Slope criteria for parallel and perpendicular lines. Now, slope is the ratio of the change in rise, that is y coordinate, that is dy. Rise is always vertical, to the corresponding change in the run means horizontal. So dx. dy by dx is slope. Now, slope criteria suggests a method for proving the relationship between lines based on the comparison of slopes of the lines. So now, over here, this is very important. Let us see, for example, based on the slope criteria. If there are two lines, how are they parallel or how are they perpendicular? If the slope is same, if the parallel lines have same slope, then it is parallel. If the two lines have same slope, then it is parallel line. This is slope criteria. Basically, based on the slope or the relationship of the slope, we can tell what lines are they. Same way for perpendicular, we can tell perpendicular slopes are based on negative reciprocal, or imagine you have the slopes of these two lines. Now, I'll just give you example 1 by 3 and minus 3. Whenever you multiply these two slopes, you must get negative 1. So if the product of the two slopes are negative 1, then they are perpendicular. So this is the thing. Now we will see a problem over here. Determine whether line AB and line CD are parallel, perpendicular, or neither for A. The point A is at 3, 6, B is at minus 9, 2, C is at 5, 4, and D is at 2, 3. Graph each line to verify your answer. So first we need to graph, that is point A is at, how do we graph is, where is this is the x-axis, the horizontal, and y the vertical. Over here the scale is 2, 4, 6, so 3 is somewhere over here and the 6 is over here, so this is the first point A. B is minus 9 over here and 2 is over here, so B. And then draw a straight line between those 2 points. Same way for C. C is 5, that is somewhere over here, and 4, so this is the point. And D is 2 and 3, that is over here. Draw a straight line. You will get the two lines. So looking at this, you can tell it cannot be perpendicular. It should be parallel or not parallel. So you can, eliminate this completely. You can eliminate this completely. You can just tell whether this or this. Now let us see how do we exactly find it. Use the slope formula and find it. You know the 2 points. So this will be x1, y1, x2, y2. So now use the formula y2 minus y1 divided by x2 minus x1 and find it. So y2 is 2 minus 6. Same way, minus 9 minus x1 is 3. Put it in the calculator, you'll get the answer 1 by 3. Now same thing, do it for the other line. See, so other points, CD, x1, y1, x2, y2, and you will get the answer. So over here it is y2 is 3 minus 4 divided by 2 minus 5. Put in the calculator, you will be getting the answer 1 by 3 and 1 by 3. Here you can see the slopes are same, therefore they are parallel lines. So this is how we get it. So I'm sorry, this is not pines, it's lines. I just realized it. Okay, it's parallel lines. Anyways, now let's go to the next problem. Determine line relationship when given graphs. the graphs are given over here in this case. See, in this previous one, the graphs were not given. We had been given points. Now, let us see. They are asked us to find whether RS and TU are perpendicular, parallel, or neither. So obviously you can rule out parallel because they're intersecting. This is not true. It should be the perpendicular or neither. Let's see them. And the points are there. See the points T, U, S, and R. Same thing, just like what we have done before. You need to use the slope formula. Let's first write the points. For line RS, the R points are -8, -3, S is 6, and 7. Same way for T, -6, -4, 6, 0, 0. Now use the slope formula and write it x1, y1, x2, y2. Just substitute and solve over here. You will get uh, y2 minus y1. y2 is 7 minus of -3. So use the bracket divided by 6 minus of -8 equals to, over here it'll be 10, and over here it'll be, this minus minus becomes plus. So it'll be, add them all, 10 by 14, it's 5 by 7. Same way, find the slope over here for the next line, 0 minus 6, and 0 minus of -4. It'll be -6 by 4. It's -3 by 2. It's not over. Now you need to multiply these both slopes. You got the slopes, multiply them. Now when you multiply over here, you're getting the answer -1.07. This is not perpendicular. If it was to be perpendicular, you had to get exactly -1. But this is not -1, it's -1.07. So they're not perpendicular. So they're neither. Basically, they're neither parallel nor perpendicular. So same way, let's do one more problem. Over here again, the graphs are given. The line EF and DG. So same like what we have done before. So what I would ask you now is please pause the video, try this by yourself, and then continue with the explanation together. I hope at least some of you have tried to, try this problem. But now we will just quickly look at this. EF, write the given points, E and F. DG, write the given points over here. Then use the slope formula, y2 minus y1. So over here, this is x1, y1, x2, y2. Just apply over here, -1, -6 divided by 6 minus 3, and write the answer. Same way, slope of dg, it'll be 5 minus of -1, 12 minus of -2. Get the answers. Now, over here, all you need to do is multiply the slopes, multiply them. When you multiply them, we are getting exactly -1. How? Because the 7 cancels over here, numerator, denominator, 3 cancels. Only -1 remains. Therefore, they are perpendicular lines. So this is so these are perpendicular lines. That's the answer.